months startups under his belt, as well as a few extra pounds, as he's so kind to tell me. He's probably just going to run some laps across the stage. He's here to talk to us about our role in technology and the role technology has in future years to come, I think. So please join me in welcoming David Carvalhão.
Well, good morning, everyone. This has got to be the longest stage I've ever been in. First of all, I would like to thank all of you for being here this morning. I am very excited and humbled to be speaking in front of some of the brightest minds that this country has. And what I'm bringing you here today is not only a presentation per se, but it's going to be a challenge. A challenge that I believe you and your participation can be pivotal in changing. So the title of my presentation is Your Computer Will Use You. And some years ago, in the late 80s, early 90s, a guy called Ted Kaczynski started thinking about the future of tech, and he realized that most likely one day machines would rule the world. And this upset him a bit, and he decided to do something about this. And what he did earned him the tender nickname from the press of the Unabomber, because he started sending out bombs to tech people, to researchers, to developers, and the reason why he did that is because he believed that the machines would rule the world not in a dystopian view of this process as we are used to seeing. It was not a Terminator like machines are going to take over the world, but he believed that humans would create a society that would be so dependent on technology, it would be so based on the usage of our tools that we would willingly hand over control of society to computers and machines, because we as humans would not have the capacity to manage such complexity. So this got me thinking. Eventually was caught, and no more bombs for now, at least not these ones. And this got me thinking on how the future of tech was going to impact us as societies. And the result of that work was the creation of a model in which the variable I thought would be most interesting to analyze, to try to understand what may come, was cognitive effort. So I created a small pyramid of 5 levels. Why a pyramid? Well, because it looks cool. And these 5 levels are directly related to the cognitive effort that is required by humans to perform a certain task. So at the base of this pyramid, and the reason why it's called level 0 is because I consider that at this level there's almost zero cognitive effort, you have the repetitive manual labor. Level 1, you have repetitive intellectual labor. Level 2, you have the interface between chaotic and non-chaotic systems, and we're going to see further on what this means. Then chaotic and chaotic systems. And at the top of the pyramid, we have the type of work that demands most cognitive effort, which is pure creation and R&D. So if we take level 0, and a good example of level 0 would be agriculture or manufacture, and I mean manufacture like actually done by hand. It involves the type of work that is mostly committed to muscle memory. So when people are undertaking this type of work, they're mostly handling physical objects. Mostly it's a repetitive action, so they're using their muscles, their hands, to perform the same action over and over again, and the decision-making process is extremely reduced. So if you consider this type of work, you can, well, very quickly see that already in the late 19th century and early 20th century, technology in the form of the Industrial Revolution started addressing this type of labor. And the result was that, well, in the first stage, it was about 90% of the labor was displaced from these activities, because now machines were doing, one machine was doing the job of a bunch of people. Then there was some reabsorption by the market, because while we were producing more, we were also generating more wealth, which meant that now people had more ability to buy stuff, and industry needed to produce more stuff. So there was, you know, a rebalancing of the market, and we ended up with about Pareto's law. So about 80% of the labor went away, and the 20% of the labor that remained became a bit more specialized. Now, once again, this level is under attack by the upcoming technologies, such as general purpose robotics, like the one you see there from ABB, which are basically robots that are two arms, two almost human arms. And the reason why this is so relevant is because try to think on the impact of general purpose computing. Before you had general purpose computing, computers were extremely specialized and extremely expensive machines. They were very good at what they did, but extremely expensive because you were making just a couple of them for banks or whatnot. Once you started producing computers that could be easily adapted to a number of functions, price started tumbling immediately. And the result of that is that although we had computers that were not as specialized, not as good at performing individual tasks, now these computers were cheap enough that in terms of the efficiency they had was good enough for the price that we were getting for us to basically start applying them everywhere. The same thing has happened with robotics. So up until recently, robots were extremely specialized machines that were used to do one function very, very well in an assembly line or something. Now, with the creation of general purpose robots, which are not as efficient as those very specialized robots, but because we are producing them by the millions, they become cheap enough that it becomes efficient to replace human beings with these robots. And if you doubt that, that robot that you see there from ABB, I can tell you that 1.2 million of these robots have been acquired in 2013 by Foxconn, which is the company that produces your iPhones and your MacBooks and your Samsungs, the Chinese company. And they bought 1.2 million robots to replace Chinese workers. And when you start using robotics to replace Chinese workers, which are not by far the most expensive workers in the marketplace, you know that something is happening. The other technology that is starting to attack this level is Industry 2.0, also known as the additive manufacture, basically 3D printing. And this is becoming disruptive because the technology is becoming good enough that it is now feasible for a certain class of objects for you not to purchase them from a retailer, but to have them produced at your own house, and you just download the schematics. And this is extremely important because you have just replaced a huge value chain that implied carrying the raw materials to a company, having these raw materials turned into a product, having this product taken to a retailer, the retailer sells them to you and you carry them back home. You just reduced this entire level to downloading schematics and printing them at your place. Right now it's still incipient, but the way we're seeing things progressing, this will also be a huge threat to this level. So then we have level 1. Level 1 is repetitive intellectual labor. The best examples that we had of this type of labor have almost become extinct. A good example was some years back, a lot of years back, before I was born, fortunately, people would spend an inordinate number of hours performing hand calculations and hand copying. So before Xerox machines, whenever you did a copy of a document, someone would actually type in a typewriter a copy of that document. Whenever you needed to make accounting in a huge bank, you would have these enormous offices filled with people whose only function was to do hand calculations. And this for us nowadays seems so foreign, and it is just because we have completely replaced it with informatic office productivity. So we have replaced a huge amount of workers, once again, by a few machines that do an enormous number of calculations. And of course, also the internet has allowed us to share our work in a way that now, well, we don't have to repeat stuff that was done by a human on the other side of the earth, thus further reducing the need for repetitive intellectual work. And now we start reaching the interesting levels. So level 2 is the interface between chaotic and non-chaotic systems. And this warrants some explanation. So a good example of this interface is driving a car. Your car is mostly a non-chaotic system. You have a definite and set number of operations that you can perform on a car. You can press the throttle, you can press the brake, you can change gears, you can move around the steering wheel. But those are a limited number of operations that produce, hopefully, a limited number of results. Obrigado. A limited number of results. And the purpose of the human being in this level is to read a chaotic world, the world around us. When you're driving, anything can happen. And it is up for the human being to perform the cognitive labor of identifying the situation which is chaotic, which may have any number of outcomes, and to map this into the appropriate actions to be performed on a non-chaotic system. Another good example of this is customer service. When you call customer service from a company, what that person that is doing is they are transforming a customer request, which can be the strangest of things, and they're trying to map that into a set number of processes that the company has inside it. So they're trying to figure out what processes they need to activate in order to fulfill that customer request. And so this type of work, it handles sometimes abstract objects, concepts, sometimes it handles physical objects. It has a repetitive component to it. When you're driving, you're basically repeating the same movements. It is somewhat creative, and if you doubt that it can be somewhat creative, you should see my girlfriend driving. And it involves bounded decision making, because the number of possibilities, the number of things that you can activate in response to an event is limited. Well, I am speaking to the right crowd for you not to be surprised when I tell you that this level is currently under attack. And it is under attack by machine learning, which is displacing the process in which we interpret a complex reality and we map it to a set number of outcomes. It is being displaced by self-care, because, let's face it, how many of you have even entered the physical bank in the last year? How many of you have interacted with someone from a bank in the last year? Most of you are just using home banking, and you are accessing directly. You are yourselves being the middleman, being the interface between your request, which is chaotic, and the non-chaotic reality of the bank. And of course, autonomous transportation. And just to put things into perspective, autonomous transportation alone represents 11% of all jobs worldwide. So 11% of all human beings on Earth are tasked with driving your cars, your motorcycles, the airplanes, the boats, and whatnot. 11%. So the tendency here is going to be eventually, I'm not saying this is going to happen next year, but slowly it's going to be to push people into the higher levels. And the higher levels are level 3, chaotic to chaotic interface. This is perhaps the one you are most accustomed with because, well, I would say that most people here are engineers. And in engineering, what you're doing is you are trying to map a chaotic reality, which is the requirements that you get, into a chaotic system, which is the number of possibilities you have with the tools you have at your disposal. It is arguable that the number of options also is limited, but it is limited in a way that allows for so many combinations that, you know, for the sake of approximation, we're all engineers, we can say it's a chaotic system. And this one still has the bounded decision making attached to it because of the finite number of possibilities offered by the tools that we have. And of course, we have level 4, which is creative and R&D labor, which the biggest difference is that the decision making is completely unbounded. Because, you know, if your tool doesn't do something, you just create a new tool. You just create something new from scratch to address the need that you have. So, when you start analyzing this push, you are quickly going to realize that it will be very hard to convert so many workers from the lower levels into engineers and creators. Society will just not accommodate that. And a study performed by the Oxford Martin School and the World Bank came to the conclusion that until 2025 to 2030, about 70% of the world jobs in the most developed regions of the world would be in high risk of automation. So what you have here in black is the current unemployment numbers, averaged, and what you have, well, I didn't say white, but what you have next to it is the percentage of jobs that are at high risk of automation. Now, it doesn't take a lot of thinking to realize that our society is not ready for this. If tomorrow we were to have 25, 30% unemployment in any developed country, the government would collapse. We are not ready as a society to handle this. And we need to be. So, there are some solutions already being thought out, and the first of which is the institution of a universal basic income, which means that just because you exist, you get an allowance. You get money just because you're a citizen of a country. And some experiments have been run in San Francisco and in Norway with amazing results. And the amazing thing is, when they started handing out money to people, to control groups of people, to be sure, but when they started handing out money, the result was not, as a lot of people predicted, that people will just stay home and watch Game of Thrones. What happened was about 20% of the people stayed home and watched Game of Thrones all day. The others saw this as an opportunity to empower themselves to address career paths that were closer to their desires, closer to their dreams, but they kept working. And a smaller percentage of these, about 20%, decided to use this security that was provided by, this guaranteed source of income to start their own companies and their own projects. Which 20%, I don't know if you're aware, but it's a huge number in terms of entrepreneurial capacity. So another of the obstacles that is raised to an approach such as this is that it will not be sustainable in the medium term to have such a scheme. The thing is, when you start automating, things start becoming interesting on the economical point of view. So if you start removing humans from the value chain and you now automate everything, now you have machines creating the machines. And you have these machines that were created by the other machines that are going out and collecting the raw materials. And they are automatically transporting these raw materials into the industries of this world, where other machines turn these raw materials into goods that are now transported back to you. And when all of the work starts being performed by machines, the cost of any goods or service starts becoming the cost of operating those machines, the cost of energy. So the capital cost, the cost of investing in buying those machines, becomes negligible, because now you can spread that investment over a large number of items. It starts becoming negligible, and the cost of that good and service approaches with time the cost of energy. So as long as we can keep the cost of energy low, we should be able to maintain a universal basic income. But there is a very strange aspect of such a situation that must also be addressed, which is our societies are built around the concept that we need to work, are built around the concept that my identity as an individual is connected to what I do for a living. And usually, the second question you get asked when you meet someone after "what's your name?" is "what do you do?" When I was just introduced now, the first thing that they told you was, "Here's David." Second thing that they told you, how many companies I created. So that's our business card, that's our presentation card to society. And we need to try to understand what will our social identity be when most of the people around us are not working, not because they don't want to work, but because there are just no jobs for them. And if you believe that this is not an important issue, I can tell you that if you have ever witnessed in today's society, when a productive member of society, someone that wants to work, loses their job, their sense of self-worth, of self-esteem, and their placement in society completely collapses. Because now they are just seen as that unemployed guy, that guy that can't get a job, that guy that sits around and does nothing. And we need to also design our societies in a way that if we come to this point, people will still retain their sense of self-worth, people will still retain their identity. Of course, we are technologists, and there are always ways that we can use technology to address some of the technological problems. And what we can do is we can look at technology as an expander of human capability that will allow us, in an ever more automated world, to keep ourselves relevant in this world, to keep the human activity as an important and a needed part of this value chain. And technologies that are being used nowadays are what they call intuitive AI. I really don't like using the word AI. I prefer machine learning, but okay. Intuitive AI, in which a machine learning algorithm connected with a genetic algorithm basically tries to create possible solutions within a set of restraints that are given to the computer by a human, and then within those restraints comes up with a bunch of solutions, allowing then the human to select the best solutions, and then it becomes an iterative process. So this complemented, augmented way of producing new designs, of producing new concepts, is probably one of the ways that humans can stay relevant longer. Another thing that has been invested in recently is brain-computer interfaces. So, I'm going to have some water. There has been significant investment around the world in creating devices. There's this new company, not new, it's like 6 or 7 years, called BrainGate, And they're creating chips that interface directly with human brains, allowing us to directly communicate and access a computer's capabilities. And the objective of such an interface could be to enhance human memory, give us new senses that we still don't possess, give us new signals that we can capture directly by our brain that now we can't, give us additional computing capability that we now don't have. And by expanding our capabilities using computers, we can perhaps remain relevant. But when you start really thinking about this, another question comes up, which is computers eventually will be doing most of the work. They will be doing the heavy lifting computation. They would be reading all these signals and bringing them in directly into our brains. They would probably be the ones acting on our outputs, on the commands we would give them, and our brains would basically be a decision center. So eventually, we would be doing the smaller part of this work. Most of the heavy lifting would be done by computers. And when we reach that stage, doesn't this sound familiar to you guys? When we reach this stage, won't we have become just a coprocessor for that computer system? A specialized coprocessor that makes decisions? And if you think that you are in control, what do you call that black box that is your computer that performs operations for you because you're the one providing the inputs? So when all of our inputs are being provided by machines and our outputs are being delivered by machines and we're just making decisions, who's really in charge? Are we running the computers, or are the computers using us as a very specialized biological coprocessor that does something they're not really good at? And when we reach that stage, will the Unabomber not have been right about this idea? Will we not have delivered complete control to machines? So, I don't have an answer for this. One thing is certain, is that in every religion in the world that has a concept of paradise, in that concept of paradise, people don't work. So there's an underlying motto for the human species that the image of perfection in life includes not working. In Judaic-Christian religions, which are the most prevalent in the Western world, labor, as in work you do to survive, not for pleasure, is associated as a punitive action by gods after you were thrown out of the paradise. So, in a way, all this path that we are now undertaking may end up in that dystopian vision of Ted Kaczynski, the Unabomber, or it could end up very close to our concept of paradise. The thing is, for us to be able to guarantee that we are getting closer to the paradise view of the world than the dystopian one, requires a new type of person, a new type of entity in the world. So, the same way that in the past, when war was the most common tool for societal change, eventually warriors realized this. They realized the power they had at their disposal. And you had the appearance of the warrior philosopher. And later on, when politics was the main societal change driver, you had the appearance of the politician philosopher. And throughout human history, you had the religious philosopher because of the impact that religion can have on society. Don't we need now, in which technology is becoming the most prevalent force of societal change, don't we need to have now techno-philosophers? To have people that are deeply involved with technology, but also thinking about the impacts of this technology in society, actively addressing and actively participating in these discussions about the impacts of technology that all of us are developing right now are going to have in society. Having the discussions on how better to manage these technologies. Because we have a tendency as technologists, and I speak for myself, that we have a tendency to close ourselves in our own field. We have the tendency to do technology just because it's cool, just because it can be done. And we need to get out of this little box, and we need to come out and start participating actively and demand that these discussions come up, so that the technology we create can be used to carry us in the direction of that paradise. So that's the challenge that I bring you here today. The world as we are building it needs you. It needs you to be involved in more than just creating technology. It needs you to be involved in these discussions. It needs you to be involved in shaping this world.